In the last video, I fired up my video card and did some full screen fills of color from black to red, green, blue, and white. And that all seemed to be working okay, or as I would expect it at that point. In this video, I thought I'd go a little bit deeper into how I'm starting to write to the video card memory and try to get something other than just solid screens of color. So maybe as a reminder, this is the address space that I am using on this system. So I have a 1 megabyte address space. The first 640K are for RAM, the top 256K are for ROM. And I have video memory sitting from A through the end of B thousands. So A0000 through BFFFF would be my video RAM. And I have 128K of video RAM on my video card. And that video card looks something like this. And that's what's sitting here at the moment. And I have these four 32K memory chips that are sitting over here. These are dual port memory, which allows both my 286 processor to access that memory pretty much directly on one side of it, or on the other side, the rest of the circuit here can read out that memory. And as a reminder, I'm not doing any really contention management at this point, so there is some risk that I could have a pixel here or there that doesn't come through quite right if there is that contention. And we'll see if I run into that or not. So far, I've not seen any of that in this specific build. Maybe some things to point out. These resistors over here, I did for now just put those in little sockets so that I can change out the resistor values pretty easily. And so far the resistors I have in there are probably about right. So I might desolder the sockets and actually solder the resistors right into the board at some point here coming up. Since the last video, I did make a change, and one of the things I had commented on the video output is I've seen a little bit of, I'm calling it vertical banding, or slight lines, or you could see the edges of the columns basically. And that came down to my 74-161s. My schematic was showing LSs, but I thought I would try some HC, the HC family of chips. So 74HC161 for these, and then these down here. And that's where I was running into that issue. So I reverted back to LS, and all of that vertical banding is completely gone. And the screen output is looking quite good at this point. Maybe another comment, as I've been working on the system and just kind of testing things and playing with things, I have noticed that power distribution is somewhat of a challenge. And so you're going to see that actually my voltage here when I turn this on, I've bumped up my voltage coming into this a bit. So maybe these chips here are probably on the high side of where I want them, and the stuff way down to the lower right, and probably this video card are probably on the low side of what I want to see. So that'll be something in my next revision of a system board. I'll improve that. You know, I knew my design had a marginal video or marginal power distribution in it. You know, I don't have an inner plane for VCC and ground, and I didn't go with crazy large tracks or traces for VCC and ground. They are larger than the rest of the traces, but probably not large enough. I don't know if I want to go to a 4-layer board just because of cost. To the size of this, that would be pretty expensive, but I'll have to see if I can get creative and get some better power distribution through the system. Or maybe even I bring the power in more center and fan it out. We'll see what that looks like. But that would be something I know is something that I'm running into. And I will note at this point, I am still running 9 megahertz for the processor. So I have everything running, and I'm using a 36 megahertz oscillator, which is 18 into my system and 9 at the processor here. So that's what you'll see. As a reminder, the video memory, I have those 4 chips, and basically I've paired them up so that I have a pair of them that are acting as the low and the high byte. For the 64K, that would be this upper memory, which would be the lower part of my screen. And then I have 64K for the lower part of the memory, which is the upper part of my screen. So this A0000 actually starts at the top of my video display, and then it works on down to BFFFF at the bottom of my video display. And then the way I've set this up is that my 286 can access that memory, and then the VGA out can also access that memory. And this card I had updated from previous designs on my other builds to be a 16-bit addressable. So from the 286 I can access the video RAM basically as just 16-bit memory. It's that easy. And then the VGA out is automatically cycling through the low and the high to send the appropriate bytes out to the VGA output. If I maybe zoom into that for a minute, and I have my 128K of video RAM consisting of those 4 chips. My target is 320 by 240 for resolution with 8 bits per pixel for color data. So for every pixel I have 8 bits or a byte of data to represent color. And I'm doing red, 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 green, 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 blue, blue. So those are the way I'm doing the 8 bits. Now, I don't need this much memory to do that resolution. I actually only need 96, but to really support the low and the high, I need pairs. And so I do need 4 of these chips, which got me 128. But if I look at what I'm actually going to be using for the video output, I don't need to go to 512 pixels wide or 256 vertical. And that's what that memory would support, is 512 by 256. I'm going to use a subset of that, which is my 320 by 240. So I can go from, I'll call it pixel 0 over to pixel 319. That's my 320 wide. And I go from 0 down to 239. That's my 240 high. And that's what I'm going to be using. And that does mean then that all of this other space outside of that gray rectangle or white rectangle is available for other things. So I can use that as system memory. I can use that as memory to cache sprites or cache other video elements. Whatever I want to do with that memory, it is available for me to use. So it's not a lot of memory, but it's enough that I can definitely be building sprites and other calculated type of content prior to moving it into the primary viewable video RAM. And then if I'm looking at this as my screen, this rectangle here, I'm going to start out with A0000 as this very first pixel. And then this very first pixel down here is going to be B0000, and then working my way over accordingly. Now the nice thing about this is if I'm at a position and I want to go to the next line, I can just add 512 to my address, and that drops me down a line. I can add 1 to the address, and that'll move me over a pixel. So that's going to be pretty straightforward, and that's part of the reason too I set it up this way, is just mentally I can kind of keep this straight. I just know it's a clean 512. Every 512 takes me down a line. And one of the challenges I'm going to have though is I do have 2 separate 64K segments. So in my assembly code, I'm going to have to deal with jumping between segments of this A and the B as appropriate. So I started getting into the assembly coding, and maybe here's an example of me clearing the screen. So this is an init procedure I put together for the video card. And in it, basically, I am going to go out and say, grab B000 and put that into my ES, my extra segment. And so now that will point to my lower part of my screen as far as memory. And then from that, I just simply cycle through it and I fill in a color. And the color that I move into each of the pixels is 0, which would be black. And in this case, I'm not doing it byte by byte. I'm doing it word by word because it is a 16-bit addressable card. So I'm just filling in two bytes at a time saying black, black. And then I run to the next pair of bytes and put in black, black. And I do that for the entire lower half of the screen. And then I come in and I decrement 1,000 from the B1000, which takes me down to the A1000. And then I go through the same process again and clear the top half of the screen. And then when it decrements, I should be down at this 9,000, which I say, okay, stop at that point. Don't go any further because you've finished processing everything on the screen. So this is how I'm clearing the screen. And I could probably actually shorten this up a bit because I am clearing all of the data, even the parts that aren't visible on the screen. But this is where I'm at for the moment for clearing the screen. And I do that when I turn on my system. And I do that right away. And the nice thing about the video card is I have instant access to outputting to it. So as soon as I can read and write memory addresses, I can be writing to the screen. I don't have to initialize an LCD. I don't have to initialize a VIA or a PPI or anything. It's just instant right to a pixel address and out to the screen it goes, which is quite nice. Now, when I first turn on this card, the memory is uninitialized, and you probably saw in the last video that I would get kind of a white noise pattern, just showing that. And then in my last video, I went later in my code and then set it to black, and then I went to red, green, blue, and white. Well, now I'm going to do the initialization as soon as my code starts up. So really, you don't even see that snow pattern, basically that white noise pattern, because by the time the monitor even senses the signal, it's already set everything to black, which is nice. So it comes up with a black screen. Then I had to get into how am I going to actually write characters to the screen. This LCD down here is fine, and I can output to this little OLED if I want to. I could also write to my computer through the serial here through SPI, and that's fine. But I want to start writing to the VGA screen as my primary output and stop using these other things that are, maybe they'll have a more specific purpose when I'm debugging or something. So I set up in my code just a bunch of pixel mapping for different characters, and this is probably a pretty verbose way compared to what I've seen some other examples, but this just lets me visually see what these characters look like. So I've set up a whole series of these mappings. So a space, I can go up to, you can see here, 8 by 8, but the first font I've set up, I'll call it a font, is a 5 by 7. So I'll have 5 characters or 5 bits wide by 7 vertical. And like in this first scenario, I'm saying for a space, which is ASCII hex 20, which is at the beginning of my character map data, it's just all zeros. So if I hit the space bar, it's going to ignore all these bits and jump to the next location for a character. If I type an exclamation point wherever there's a 1, that's going to show up as pixels turned on, and that process repeats. So I've got this for all of the characters that I want to support at the moment. So I'm just defining a byte and saying, okay, you have 8 bytes, of which I'm really only using 7 for now, and I'm using the first 5 bits in each byte to help me understand what a character looks like when I want to write it to my VGA output. Then I had to put in some code that actually simply, basically, it goes out and if I hit a key on the keyboard, first of all, I have to convert it from a scan code to an ASCII code. And then I need to go look up in that character map that I just showed the appropriate character and get the pixel data for that character. And then what you see on the screen here, I'm basically then running through and saying, okay, grab that first row, that first byte of pixel data for the character, and just check each of the columns. And if it's set, draw a pixel. Otherwise, go to the next one. And once I'm done with a row, jump to the next row, the next row of pixels within a character, and just repeat that process. So that's what this code is doing. I know this is not the most efficient way probably to do it. My first goal is just, can I mentally get through this and make it work? And then later I'll come back and see how can I optimize this. And if any of you have suggestions on better ways to do this, which I know have to exist, do let me know, and I can adjust this code as I go. This processing a char, within it you can see that I call a draw pixel. Well, this is what the draw pixel looks like. I'm basically now going to go out and I'm going to say, now in this case, this draw pixel only supports the first 64K of my VRAM. I've got to make it a little bit more dynamic to support the second 64K, but I needed to start somewhere, so this is where I started. Basically it gets me, so my ES is pointing to the first 64K of memory, and then I just hard-coded a color for now. So this is a color you'll see, whatever it is, a blue, green, or teal type color, if I remember right, and basically going to write that to a pixel. So, and then the question is where. So I know it's going to be within the first 64K, and then I'm using BX to track where that pixel is at. And BX, I first of all have to know where's my current cursor position. So as I'm typing, the cursor is moving, and I'm not showing a visible cursor, but it's tracking where it's at. And then within the character that I'm currently drawing, which pixel within the character am I at? That's these offsets. So I add all of that up. That tells me where to draw a pixel. And then I draw the pixel of the appropriate color. Later I'll pull a color from a variable, and but for now I thought let's just quickly hard code a color and call it good. I also have to fill regions, and I just grabbed a snippet here, and you're going to see this later when I turn on the system what the output looks like. But when the screen first comes up, I'm going to put a quick little border around it with some different colors just to use as kind of a QA check. So as I go through things, I can make sure I'm seeing my border, seeing the right colors. But this is basically saying, okay, I want to go out to here I'm using ES to point to B1000, which would be my lower half of my video memory or screen, lower half of the screen. And then within that, I want to go to pixel 1. So not 0, but pixel 1. I'm going to leave a 1 pixel border or unused location on the far first column. So this says go to the second column and write a color of 1C and then add 512. So drop down a row and repeat. And it does that for the entire left portion of my upper portion of the screen. So that'll draw basically a vertical line. Or sorry, this is the bottom, it's the B. If I change this to an A, it'd be the upper left. So this is the lower left, like it says left bar lower, and it's going to just simply draw a vertical bar. And then I have some code that draws a pattern, and this I'm going to jump down to the lower part of memory and actually go just initially start all the way at B400. So that's going to be the bottom half of the screen, and not even at the top of the bottom half, but further down, which you'll see when this gets rendered out, and start 32 pixels into from the left. And then I simply run through and I draw a pattern, and the color I'm going to use, basically I'm going to cycle from 0 all the way up to 255. So I'm going to show a pattern of every single possible color as a vertical bar within a rectangle on the bottom half of my screen. And after I show that, you can come back and look at this code if you want. And again, I'm sure there's better ways to do a lot of this, but this is how I am doing it currently. Now, when I was going through working on this code, I ran into an issue, and this was sample output. Right here, these dots I know are probably hard to see, but basically I'm zoomed into this a little bit, but there's a line right here that you can't see that is the split between my upper half of my memory, the top half of the screen, 64K, and the bottom half. And I just simply wrote code to put in 2 dots vertical, space over, and put 2 dots vertical. And I just wanted to quickly test, could I write to a certain spot and see what I expected? And I did that to both upper and lower VRAM. Lower, this is what I expected to see. So double dot vertical, come over, double dot vertical, and that looked good. But what I was getting here, there's an extra dot, and I can zoom into this a little bit. I didn't want to see this. So I've got a dot, 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 but then I've got 2 here. And I was finding that for the upper 64, the memory for the upper part of the video, which would be my A0000 segment, anytime I would write to an odd address, I was getting duplicated data down here. And I'm like, what's going on with that? My first assumption, of course, was it was just coding, because I'm learning a lot of assembly coding, and there's a tremendous amount of room for error on my coding. So I did some debugging, and after a little bit I realized I don't think it's an actual coding issue. It seemed like it was a hardware issue. So interestingly, I went back and looked at my schematic, and for this says lower 64K, which is the A0000, which is the top part of my screen again. I've got the paired static RAMs, so this is my 64K, and I've got the low and the high byte, and I missed updating one of these net labels, and over to the left you can see it goes from VA 10, 11, 12. That's what I should see over here, 10, 11, 12. Well, I have 2 10s, and that basically results in every time I write to that odd address, I'm getting that duplicated pixel, because this isn't an 11, it's a 10 on that also. So that was a problem. So then I had to go figure out how am I going to fix that. And this is just zoomed into the specific IC that has the issue underneath it. And what you're seeing here is the PLCC socket. So unfortunately, the traces I need to get to are underneath the socket. So what I had to do is desolder and pull out that socket. and then I cut the trace coming into this. This is the error right here. This should be VQ3 is what it should say. So I had to cut this trace and also disconnect it from this other, what's properly set up as VQ2. So VQ1, 2, 3, 4, 5 is what it should be showing, because these VAs connect to the VQs further up in my diagram. So I pulled the socket, I did some trace cutting. So here you can see the sockets cut out. I cut the trace here, I cut the trace here. That isolated this pin now, and also isolated this and its corresponding pin to the next memory over. So I had to fix that. So then I flipped the card over and I ran some bodge wires from this resistor array, which was great that I had that there, and connected the proper pins back up. So this is a coded wire, so it may look like it's shorting out here. It's not, but I now have corrected those signals so that if I back up a slide, now it is VA 10, 11, 12. And then after I did that, the issue was resolved. So I confirmed that all was good to go with that. Now I have a lot more work to do, and this is just a start of a list. So right now, some of the code, or what I'm going to show running, really is only working within 64K segments at a time. I need to write some routines that make that transparent, so I can just write to a location by horizontal and vertical location XY coordinates for pixels, and it will just automatically set the segment accordingly depending on what I'm writing and where. So I'll work on that, and I have ideas of how to do that. I just need to get it implemented. I am filling some regions with the current code, but it's all pretty specific for test code. I need to make some generic procedures or routines, like a fill region where I can give it an upper corner XY and a lower corner XY, and then have it fill in everything in between with a specified color. And so I'll work on getting that implemented. I know there's a lot of room for improvement in my code, so I'll be working on that as I go forward, and probably can majorly improve performance as I get through that. So that's something I'll need to work on. The code I'm going to show you also coming up here, I'm not doing any caching or paging. I am writing directly to the video RAM from the processor. I know my previous experience on my 65816 build is that if I have something that has to do a lot of calculations, let's say moving sprites or running through some type of a formula to come up with the what goes into the pixel location, I'm better off caching that. First of all, do the calculation, write it to maybe RAM, and then from RAM just do a dump of memory to memory. And I guess I would call that paging. So I could write a page of video memory to the RAM, get it all built out, and then tell the video card just swap it over. And that's what I've done in previous systems. So I have none of that in here yet. It's just simply writing directly to video RAM. So keep that in mind if you see part of the screen refreshing or drawing. I think in the future I can minimize that by doing some of that. And I might not have to write it to system memory. I might write it to that unused video RAM, and then once I have everything set up there, then I can just bring in those pieces into the main video RAM. I do want to get into software sprites. I'm not even thinking about starting sprite work yet, but that is on my list, on my relatively short list. And then I want to do some just tests, playback of animated content, and see how everything looks like it's running on the system. At what speed, what kind of performance can I get if I want a ship to fly across the screen, or a Mario to run across the screen, or whatever it might be. And with that, I thought I would go ahead and fire up the system and just kind of show you. So I am recording the screen with OBS. So I'm just going out of the video card, basically through some adapters into a USB capture, and I'm recording that. So what you're going to see for the video output is coming directly out of the video card. And as a reminder, again, like I mentioned before, I'm running at a full 9 megahertz. I've bumped up my voltage. You're going to see that's probably high, pretty high on this card, but it drops fairly quickly. So some of these are probably on the upper edge of where they should be, and some of these are on the lower edge of where they should be. And I did notice that without me doing that, I was starting to have a little bit of issues, especially when I went back to these LS family instead of the HS or HC counters here, the 161s, that did have an impact. And I had to drop down to an 8 megahertz processor instead of 9. So then I upped my voltage a little bit, and now I'm back up to 9 just fine. You'll also see, if you're paying attention to what's going on here, if you can see it in the video, but some of these resistors throughout the board I've put in sockets now because I've been doing some tweaking with the keyboard and other things, and just trying to make the system work as well as possible. Okay, so with that, I'm going to go ahead and turn on my benchtop power supply, and that will get this LED on over here, just showing power's coming into that. And then I'm going to go ahead and turn on the system, and we'll see what we get here. So you can see that at least coming into here, I'm at about 5.4 volts, but by the time I get to the initial stuff over here, it's dropped to maybe 5.2, which is comfortable for these chips. I'm not worried about that. And when I'm down here, I'm probably down at like 4.7, 4.8. So that's how much of a drop I've got going on. Now, real quick note, at this 9 megahertz, you can't see this, but all my post-test passed. So it went through the RAM reading and writing and checking. It went through my VIA, my math coprocessor. And I'm really not doing much for PPI testing right now, but it is going through a harness at least to see if it can test the PPIs. And more to come on that later if you watch my previous PPI video or post-test video. And if I look at the output on the screen, you can see what I have there. So I am showing across the very top, very bottom edges a blue bar. On the left edge, 1 pixel in, I skipped the far left pixel because I often pick up noise on that very first pixel, so I'm skipping it. And then I've got a green vertical bar, and then on the far right, I've got a red vertical bar. And then that gray vertical bar, that dark gray, is really where the first 64K ends and the next 64K starts. Because remember, there's some memory at the bottom that I'm not using, and that's why that bar isn't quite in the center, because the first set of lines are 64K, and then the next is 64K minus 16, so whatever that is, 48. So you got 48K of memory instead of 64K as far as the vertical portion. And then I just simply am showing the colors from 0, and I'm counting up. So I go from the value of 0 to a 1, which would be a little bit of blue, and then I'm going to a 1, 1, 0, to a 1, 1, 1, 0, 0, etc. And I'm just working my way up and letting that go across. So I can kind of see, am I getting the colors that I would expect, and eventually get to a white at the very far right. And that's all that pattern is. But that's a quick test pattern, and I can use that to kind of look at it and say, do I see enough of a difference in some of the blues, for example? And if I don't like that, then I can come to the card, I can go to those resistors, and I can adjust the resistors a little bit. And as long as it's close or good enough, I'm not going to get too worried about it. And I'm looking at this, and it's probably good enough where it's at. I'm not real concerned. It's in the right ballpark for coloring, at least. Maybe in a future card, I could even put 8 little pots there, so I could really dial it in and not have to be messing with resistors, but good enough for now. And as I look at this, I'm not seeing any vertical lines at all. I see a little bit of maybe waves coming through. I don't see those on an actual LCD, so that's something with, I think, my capture equipment and all the cords I've got running here, because there's a pretty good distance of an HDMI cable plus a USB cable to my PC. And I think it's just picking up some noise there. So if you are picking up any like little waving going through the signal, I do not see that on an actual LCD when I hook up. So at this point, that is working. I've made it through all my inits. My screen is working. My real-time clock is working. Pretty much everything is working. Pretty much everything is working as I'd expect. And now I can come in here and I can type. So I can say "Hello World." And you can see that works fine. I can press enter and go to another line. I can press enter a few times and hit, other lines here as I go, and my typing isn't perfect here. So that all seems to be working. So in that case, I hit I fat fingered an extra square bracket and maybe an E on the line that says line E. Now, right now, that code is only supporting the top 64K. So when it wraps around, it's not going to go to the bottom part. You can see it actually wraps around to the top of the 64K. So that's some code work I've got to do so that it continues to the bottom 64K. I can hit escape and clear the screen, which just simply redraws the init. And so now I can do some more testing. And that all is working well. So that is my exciting 5x7 font. And you can see how much of the screen real estate that font will take up as I get into this. But typing is working, printing those chars is working. I'm no longer printing chars to the LCD because it really is pointless if I've got it on the VGA. And then I can hit escape to clear the screen. And in the future, of course, that escape will do different things, like maybe just clear it to a black. I don't have to repaint the test pattern or do anything like that. But for now, this is how I'm clearing the screen. That's probably it for this video. So I've spent about half an hour here just kind of going through just how I'm accessing the memory here, how I'm starting to program it, and showing the current output, which honestly, I'm happy with the current output. I'm not seeing a lot of really artifacts. The only minor issue is the very first column. I get a little bit of noise, but that I think really comes down to really how I've done the timing for my vertical horizontal refresh signals in my PLDs over here. So I could probably tweak that, but it's close enough that I'm really happy with what I've got there. And the output both to my LCD and within OBS are picking it up nicely, and that all seems good. So more to come in the future. Like I said, I've got a lot of assembly work to do, but I think I'm going to call it good for now. If you have questions, comments, suggestions, please drop a line below or reach out to me. Thanks.